study is?
Yes, so we're called Ellipsis Earth.
Ellipsis Earth?
Ellipsis Earth, yeah. And we're developing software that can detect litter from images automatically. So we have an algorithm, a piece of machine learning software, computer software, that can look at an image, a photograph, and it can spot Coca-Cola bottle, toothbrush, cotton bud, drinks container, Starbucks coffee cup, etc. Automatically.
Okay.
So what we're doing today is we're taking lots of photos of different items as training imagery to train the software so that it can recognize by itself. And the plan is that eventually we're going to have an app launching in about 6 weeks' time, and the app will enable anybody to walk around taking photos of trash. It will be uploaded, automatically detected, and then mapped onto like Google Earth, onto a map, so that we can have a big Google Earth, Google Maps of waste, of plastic litter. So you'll be able to go on the map and you'll be able to look and see where are all the bottles, where are all the fishing nets, where are all the toothbrushes, and you'll be able to see them on the map. And so then people can go and clean them. Policymakers, governments, councils can be able to act to put more trash cans where there are hot spots. Companies can pay to clean up their trash. And basically it's just providing data so that we all understand more where the trash is, because the big problem at the moment is it's all missing. We don't know. 99% of all the plastic that enters our oceans, it goes missing.
What do you mean it goes missing?
So we know that about 10 million tons per year of plastic mismanaged waste goes into our oceans, right? We only see 1% of that floating on the surface. I don't know if you've heard of
so then
the 5
because
gyres.
you think it stays...
We don't know. We don't know if it's in the top 10 meters. Maybe it's floating like a soup. We don't know if it sinks to the bottom. We don't know if it gets eaten and it's inside the animals. We've seen it, but we don't know how much. And we don't know if it ends up on the beaches. Obviously, we've seen it on the beaches. So we don't know what's the proportion. Of that 99%, maybe 98% is on the beach. Maybe 98% is on the floor, on the seabed, and only 2% is on the beach. We just don't know. But also, imagine if I said to you, okay, we have beach A and beach B. Both of them have 1 ton of plastic on them. Okay. Well, okay, we can go and clean that up. But if we know using our technology, we say beach A has 1 ton of fishing nets, fishing wire, rope, and beach B has 1 ton of toothbrushes and tampon applicators and cotton buds. Firstly, that tells us that the problem, the source, is different. And it means that the solution is different. Because if beach A, we need to go and speak to the fishing industry, we need to have legislation on fishing nets, we need to have a recycling scheme for fishing nets. Those actions are very different. Beach B, if we know what type of plastic it is, we can then say, well, this is from the sewage industry. We need to try and increase awareness around what you throw down your toilet. So we need to do some educational campaigning for the public. We need to have better filter or cleaning systems so there's less leakage from the sewage system. And we also need to have a different type of cleanup because that needs to be recycled or disposed in a different way. So you can't treat 2 different diseases with the same treatment, you know? So this is providing the information on the type and the category of the plastic, so that the responsibility is a different. We can find the source, and we can find accountability. Who is accountable? Who is responsible? And we can apply a different, correct method for the cleaning and the reduction in the future. So does that make sense?
Yeah, it makes a lot of sense, and I have a couple of questions.
Sure.
So it seems like a big organization, right?
We're very small.
Because if you're talking about so who's
So I'm the founder. I'm the founder and CEO. My name is Ellie Mackay. I founded this. We started about 3.5 years ago, developing the algorithm, trialing, making sure it's going to work. And then we launched as Ellipsis less than 1 year ago. So we're a very new startup. We've actually just been selected by Google as one of 10 global startups for sustainability. So with out of all the, I think they had about 1,200 applicants, and we got through to the final 10. So we are on an accelerator program, which is the Google Sustainability Accelerator, for startups who are changing the world. Startups who have technology that is going to help environment, education, poverty, all different areas. And we're focused on trash and waste. So we are a small company, but we are growing very, very quickly. There's a huge demand.
Giant,
we have the support of Google, we have the support of a few big companies as well, and we have a lot of demand. There's a lot of people interested because, of course, corporates want to know, brands want to know where their trash is ending up, charities, activists want to know, governments, local councils, national councils, they want to know these patterns. They want to be able to understand the behavior and the movement of trash through their system, because then you can increase the efficiency of that system. So, for example, we have in the local councils here and all over the UK, they send a truck to the beach every week to try and clean it. Sometimes there's no plastic and they wasted, you know, a whole team of people and petrol and the truck and everything and everybody's time. Sometimes they get there, maybe it's after a storm or after a bank holiday weekend or, you know, seasonal change, or maybe some big fishing net has washed up and they have too much plastic and they can't take it all and they have to leave it behind and then it goes in the sea and it causes lots of damage. So what we can do is have a system that is having imagery that's constantly monitoring. You could have CCTV cameras, or you could have somebody with a smartphone, or even you can fly a drone, or you could use satellite images. We can take imagery from any camera and then detect where the plastic is, and you can send an alert to the council to say this beach has too much fishing net on it, and they can deploy their team to go and clean it up just then. So it means they're not wasting a lot of time and resources traveling everywhere trying to find plastic. Manufacturers are also interested because there are lots of manufacturers now making things from recycled ocean plastic, right? It's gaining in popularity. People want to buy recycled materials. So you can buy things like surfboards and clothing and road surfaces made from ocean-bound plastic or recycled ocean plastic. And again, it's different. They need different types of plastic. So again, they can say, well, we need to know which beach has the most of this type of plastic, or which river or which city has the most of these type of bottles, or this particular brand, because they know that's the right type of plastic for them to recycle. And so our heat maps can again tell them, well, look, you should go and clean this street or this road or this beach or this river, because there's a high proportion of the type of plastic that you need. So again, it's like treasure hunting and telling people where the different types of treasure are.
Yeah, and then to recycle.
Exactly. So the plan is to be able to map all of the waste that's been lost to the environment. It's called mismanaged waste. Anything that didn't stay in a recycling system, in a landfill system, in containment. Something that's escaped that system, it's gone into sewage drains, storm drains, washed into the sea, blown into the water. To recapture all of it, so that we can return it back into something called the circular economy, which is the idea of maintaining and recycling materials.
The circular.
Exactly.
It's never
so,
left out or wasted.
A good example is aluminium can is very well established circular economy. They make an aluminium can of Coke fizzy drink. You buy it, you drink your drink, you throw it in the trash. Within 6 weeks, it's back on the shelf as a new can. Because aluminium has a good value to it. 75% of aluminium is recycled and it's returned back into the economy, and it can make money again as a new can. And then that goes around again and again. So when you buy a can of Coca-Cola, it's 10 times it's been a can, you know, again and again and again. So that's what we mean by circular economy. And that happens with some materials if they have a good value. Plastic at the moment, it's still cheaper to make virgin plastic than to use recycled plastic.
And it's expensive. Companies who are designing trainers, or it's quite expensive than the product.
So we don't quite have the economics there yet, but part
and
of
the most damaging, isn't it?
It is extremely damaging, because even aluminium will break down and will rust away, but plastic stays for 1,000 years. So unfortunately, the material that we're not retaining and capturing in the circular economy, the one that's being lost to the environment, is the one that has the most damage to the environment. So it's kind of a double problem there. So one of the reasons why it's expensive is because going and getting it is expensive, right? Because we don't know where to look. So if we can provide the treasure map, then going and finding it and collecting it becomes cheaper, and that then means the cost of the recycled trainers would then be slightly cheaper. What we also need to do on the other side is get more tax for plastics tax, and we need to have legislation, fines, accountability for producers who are still using virgin plastic. That needs to be very heavily fined or taxed. So then eventually the cost of printing new virgin plastic, making new plastic, will be too much, and the cost of recycled plastic will be less, and there's a tipping point.
So there's a benefit of using recycled.
And then we can recapture all of that plastic, put it back into the circular economy, and then it can go round and round like the aluminium does. At the moment, only 9% of plastic is recycled, and aluminium is 75%. So we need to just boost that. So our technology at Ellipsis is hopefully helping.
So how many right, you're here in Hyde Park.
Yes.
How many sites do you have? How many of you?
So we've done.
Where are you?
Yeah, we're based in London, and we do a lot of the training here for the algorithm. So that's what we're doing today, is training, taking training images, but then we survey all over the world. So we've surveyed the entire length of the Ganges with National Geographic. We've surveyed the Galapagos Islands, we've surveyed in the Arctic, we've surveyed in Australia, in New York. And so we're gathering imagery from around the world.
There's a big problem with country dumping their
waste
in the countries, in
and this is the problem
countries.
Is like nobody owns the oceans, right? So once something is in the ocean, it ends up on somebody else's beach. So if you go to Indonesia, it's a lot of American trash. If you go to the Philippines, it's Chinese trash. So who is responsible?
Hidden, and the way they do it is people don't know.
So this a law that's coming in place in Europe, it's currently in place in the US, and it's coming into Europe in the next year, which is called EPR, Extended Producer Responsibility. And this is going to mean that the producer, the manufacturer of the product, is responsible for it until the very end of its life. So it means that once you've bought a drinks bottle, a Pepsi bottle, Pepsi as a company is responsible for it even wherever it ends up. So if you as a consumer throw it out of the car window and you throw it into the street or you throw it into the sea, Pepsi is technically responsible for the cleanup of that. So it then puts a lot more responsibility on Pepsi to educate, if they're having to pay millions of pounds to clean up their trash, they're going to very quickly switch to a recyclable alternative and maybe use a sugarcane bottle that biodegrades, or different alternatives, metal cans, for example. So it's a really good step, and again, our data can help to verify or to validate the quantities that are ending up in different places, so that these companies are taxed the correct amount. They're not taxed too much, they're not taxed too little, because you have to be fair. We can't just go to the big names and say, well, it's all your fault, because actually there's lots of different brands that are all responsible. So what we can do is help to make sure that the accountability is fair, and therefore these brands are happy to pay what they owe. It's everybody's equal responsibility, and that will help considerably, because then there will be an incentive for those brands, those manufacturers, to educate, firstly to switch to alternatives, but also if they are putting a product out into the world that they are responsible for, liable for financially, then they will also educate their consumers. In the same way that alcoholic drinks have the warning label, and smoking packets have the warning label. Maybe we'll start to see this, where there'll be more of an enforcement and more of a responsibility and education around what to do with your plastic bottle. Don't throw it in your regular trash, it has to be recycled. It could also encourage these brands to have a return scheme, where you pay 10 cents more to have a plastic one versus an aluminium can, but then you get it back if you return that bottle. And it encourages. We used to have them. We used to have them. Exactly.
We used to take bottles back.
Exactly. So it's a step in the right direction.
So it's interesting for me to talk to you about AI, because AI is something that is used to control people, advertising, to collect their data.
People are very.
And so for me, when I asked, I was, AI, what are you doing here?
People are very scared about machine learning, AI. The same thing, we do a lot of surveying with drones.
Because it's been used against people, hasn't it? I mean, it's completely different. I really have a lot of respect for what you're doing. And
it's a positive use. I'm a big ambassador of the kind of hashtag AI for good, and also drones for good, because I'm a drone pilot. This is how I got started, was flying drones.
As well.
People are scared of drones
because the big corporations are using them to control. It's in the mind. There's an agenda where all this, all artificial intelligence and all the new technology is used to control, basically, to control and to scare people.
So I'm really proud to be part of AI for Good and Drones for Good, because what we're doing with our aerial surveys and with capturing images and with our AI, our software, is we're demonstrating that AI doesn't need to be something that's negative or scared. There are amazing uses. There are really incredible examples of machine learning and technology and imagery being used for conservation, being used to track endangered species of animals, being used to look at the health of different forests and measure the rates of deforestation. And monitoring doesn't need to be a bad word. Monitoring of people, of course, people are scared of this idea, but we do need
because it's the intention.
It depends on the intention.
I can see your intention, your passion. You're speaking with your heart, and I know that your intention is protection of our
our planet.
Other people have different intentions.
Of course.
So that's why there is that. Some people are not seeing it, but people like me are worried about.
Of course, I think it's important to recognise that there is monitoring that is for our benefit, and then there's monitoring for the wrong intentions. And the good thing is, it's 2020. We have this amazing technology. The fact that it has the potential to be used for bad doesn't mean we shouldn't use it at all. We should make sure that we are using it as much as possible for examples like this. This technology is amazing, and it saves thousands of people, thousands of hours. So it's really efficient, it's really powerful, it's really impactful, the visuals of it when you see these heat maps. So it's really powerful technology, and we shouldn't be scared of it. We should be embracing its use in the right context like this.
In the right context.
So that's what we're doing at Ellipsis.
Thank you so much.
No worries.